All right, let's look at numpy, which is the basis for a lot of the libraries we've been working with. If we look at, we're going to look at num1 through num9, NUMP, not NUMB, because we aren't num. Okay, so we import numpy. We make a list. This is a Python list, and then we can print the list. Then we can make an array in numpy by using the numpy.array command and passing it the list, and then we can print that array out. So if we run that, you can see we get, well, you can see we get the Python printed list and then the numpy printed array. All right, let's look at num2. Let's go back here. We go to num2. All right, so we import numpy. We make a list. This list looks funky, doesn't it? Because it's a list inside a list, which is perfectly acceptable in Python. You can have a list that has a list element as the first element and a list element as the second element. And we'll print that out. You can see that. Then we're going to make an array out of that in numpy, and we're going to print that array out. And let's put a wait command in there. And we'll run that and see what that happens. So that is the Python list that has a list and a list. And this is the numpy two-dimensional array. And we can then print that out and ask how many dimensions does it have. So if you don't know how many dimensions your array has, you can ask it by doing the n dimension. And you can see I made it a nice print statement here. And then I make a new Python list that has a list of numbers in the first element and a list of letters in the second element. We print that out, and then we convert that into a numpy array, and then we print that array out. Hold on a minute. And then we'll run that, and you can see this gives us how many dimensions in this array, and then we print that in a nice print statement, and then we print the numpy array out. Notice it doesn't look as pretty. And then we're putting the raw data out for our new Python list here. Then we make a numpy array. Now you're saying, wait a second. Well, for those of you who were paying attention, last week he was very specific about that they have to be all the same data types. That's one of the differences between arrays and lists. And this looks like he just made a numpy array that is different data types. Well, we'll deal with that in 1 second. All right, go to num3. It's not. It's all the same data type. If we look at num3, we do the same thing. We make a list in Python that is a list of numbers and a list of letters. We print that out. Then you can see how you can access different individual elements in that array, and it's row and then column, and it's zero based. So row 0, column 0, and row 0, column 1 is the first item in row 1. And if we look at 1, 0, that's the row 2, which is the second row and the first element. So if we run that, you can see that. You can see 1, 2, and then A and B. Makes sense, right? All right, now, here we go. If you look at line 24, you can see I make an array in NumPy out of that mixed type Python list in lists. Two lists in one list, which I said you couldn't do. And then I print it out and everything seems to be happy. No error messages, no nothing. But then I will show you the data type of that new array. And you will be surprised to see that the data type is Unicode 11. So basically it just converted into all binary data, so you now have an array, two-dimensional array that has just binary data in it, which you can't do anything with. So you really can make, it only can be one data type, but that data type, if it has a mixed data type, it's going to convert to Unicode and it's going to be useless for you. So you really can only have one data type. All right, so let's look at num4. If we look at num4, we do the same thing. I make a raw data, a 2D list in Python, but now it's both sets of numbers. I make an array out of that, and now I can start printing stuff out. So now I can print out first row, fifth element. The fifth element, yeah. So because it's zero based, 0 is equal to the first row and 4 is equal to fifth element. We can also start doing array arithmetic. So if you look at line 19, you can see I am going to add 5 to the array. Now what that does is add 5 to every element in the array. And then let's do that. We gotta wait for it over here. There we go. So there's the array, and I've added 5 to every element. So 1 plus 5 is 6. 10 plus 5 is 15, so it's added 5 to every element. But notice, because of the way I did print my array plus 5. I'm printing what would happen if I added 5 to the array. I didn't actually change the array at all. This is the original array. This is the array with added 5 to it, and you can see the original array hasn't been changed at all. If I wanted to change the array, say I wanted to multiply every element by 10, I would do the array name equals the same array name times 10. And if you look at line 26, you'll see that. And if we run that, you can see the values have actually changed because it's just printing the array. It's not printing the array times 10. Hope that makes sense. All right, let's go on to number 5. All right, so we do number 5. We're going to start doing random numbers into an array. Now, if you look at line 5 in num5, you'll see random.randomn. This takes this n, it says 1 to 100. So this is taking 100 values of random numbers from a normal distribution that has a mean of 0 and a variance of 1. And if we print that out, you will see we have the mean and the variance there. Let me put another input weight in there. Make it a little bit easier for you to see. And we got 100 values, and the mean is 0.09 and the variance is 1.08. Now, as I increase, instead of doing 100 values, I do 1,000, 10,000, 100,000. Let's see what happens here. Same sort of thing. Now you can see our mean is getting closer to 0 and our variance is getting closer to 1. The more values we read in, the closer we'll get to this normal distribution of mean of 0 and a distribution of 1. Now, all we've done is do a one-dimensional array with this, but we can still start doing some numeric calculations on here. So we can do like the mean and the variance for our values. And I just made a small two-dimensional array from random numbers, and it's 2 rows and 5 columns. Now, these are not zero-based. So 2 is actually 2 rows, and 5 is actually 5 columns. So the 2 rows would be column 0 and column 1, and the columns would be 0 through 4. Make sense? Yeah. All right, let's look at num6. All right, so in num6, we take and we make the same thing, a random number array that's 2 rows and 5 columns, and I make a list of lists in Python that's 2 lists of 5 elements, and then we make an array out of that. So now I have array 1, which is my random array, and array 2, which is my list of lists or arrays that goes 1 through 5 in the first row and 6 through 10 in the second row. We can start adding arrays together. So we can add the two arrays, and then we can multiply the array times itself. So we can then add the array 1 plus array 2, or we can multiply the two together. We can then, which is right here, let's scroll down there. We've multiplied the two arrays. We've added, those are the two arrays. We've added them together. There's array 1. There's array 2. We add them together. You can see 5 plus 1.0 is, should be, oh, it's minus 1. That's why it's minus 1. So 5 gets to 3.9. If we multiply the arrays, it's going to be this times that, and 6 times, it's going to be that times 6, and that times that. If we look at the next one, I create a new list, a new array, and what I want to do is say, is array 1 greater than array 3? So we can do comparisons, Boolean comparisons too, and then I print the two arrays out so we can check. And is minus 0.0 greater than minus 0.2 greater than minus 0.9, and it is, because 0.9 is further away from 0, so it's smaller, so you can see that we have the trues and falses going across there. If we look at num7, all right, we can make 0 arrays. If you need to make an array but have it all 0, so you want to add something to it later, you can use the 0 command. Of course, we can do a single array, a single dimensional array, which we'll call a vector, or a two-dimensional array, which we're supposed to call an array. And we can use the copy command. And remember from Python 1, if you just use the assignment command for a list, list 2 is equal to list 1, it actually makes a pointer. It doesn't actually do the copy. Same thing when you're working with arrays in numpy. So you want to use the copy command, and it works just as you would expect. If we look at num8, we make an array, and we make a list, a single element, a single dimension list in Python. We convert that into a one-dimensional array in numpy, or a vector. And we can start doing some odd copies. This is a review from some of the other, similar to the way it would have done in Python. If you remember some of the other reviews, we can copy from a particular location. So we start copying from the third position, which is 0, 1, 2, and we copy up to the fifth position, not through the fifth position, so we get 3, 4, and 5. We can also copy from position 3, which is the second, the third position, which is 0, 1, 2, and copy to the end if we leave that blank, as you see on row 15, and we can print that out. And then we can copy some arrays, but if you look, we can also put values in. If you look on line 25, from the fourth position through up to the sixth position, you can see I've converted those values to 77. So it's 1, 2, 3, 77, 77, 77, 7, and 8. And if you look at numpy, you can see I have a one-dimensional array, a two-dimensional array, and a three-dimensional array. Look at those very carefully. Those brackets are make sense, sort of, until you get to the third dimensional array, and then they get a little funky. So we have a one-dimensional array in brackets. In a two-dimensional array, we have bracket, bracket. This is the first row. This is the second row. And then you have a three-dimensional array. You have the bracket, and then you have the greater bracket, and then you have the whole bracket around the whole three-dimensional array. And we can print that out. You can see that we have a one-dimensional array. If we want to print one value, we just send it with the square brackets if you look on line 16. If we go to the next line, we're doing the same thing with a two-dimensional array. We can print the whole array here, or if you look on page 22, we're just printing a single value, which is 1, 2, which is the second row because we're counting from 0, the third value or third element because, again, we're starting with 0. We can also print an entire row from the array using just a single value if you look on page 26. We're going to be doing slicing later, and you'll see why printing and slicing is going to be exactly the same thing. If we get to the three-dimensional arrays or matrices, it's going to look very similar. You can't really visualize a cube very well, so it does the front and then the back. In the cube, it does the slices, and we can do the front slice. We can do one row from the front slice, or we can do a single value. And those are on 35. If you look on line 35, you'll see the front slice. If you look on line 39, you'll see the entire row. And if you look on 43, you can see how to get individual values. I know I'm moving fast. I want you to know how to do this. You don't need to memorize all of these because all you got to do is I can do a slice of a whole two-dimensional array. And so I gave you all these files to look through. You can note which one has what in it. So when you go to do the work, you can actually refer back to the files and see what the syntax is. Alrighty.